Hello everyone, my name is Wael Saeed. I'm a senior technical consultant at Smart Vision and your instructor during this training session, which is an introduction to IBM SPSS statistics. During this session, we'll briefly have an overview of the science of statistics, and we will know why data analysts usually apply it to support the process of decision making. Also, we will discuss the different types of data and understand what variables are and what are their types. Then we will introduce inferential statistics, but we will focus on why researchers deal with samples rather than the entire population and how they validate these samples before generalizing results to their populations. Actually, why we may need to perform a statistical analysis. Let us have a look at the very simple table and which contains a set of ages of 5 people. Now, let's try to extract as much useful information from this table in a form of a very simple in order to
have a look at this small table.
For sure, it would be much better to draw a distribution chart, which is much easier to interpret. And then, from the drawn chart or from the original table itself, we can have some observations to report, such as we can say that the oldest one in this list is Ahmed, and he is 33 years old. Also, there are two youngest people in this list, and they are both 23 years. The difference between the oldest and the youngest is 10 years. Also, we can calculate the total of ages, which is 133 years. And then divide it by the total number of people and calculate the average age, which is 27 years.
The difference between the oldest
and for sure,
and the youngest,
there are much more observations or operations which we can perform to stack as much useful information from this list that we may need for any purpose. We name these observations or operations statistical measurements. The main objective of these measurements is to summarize the information we have into simple numbers to better insights, and which is very easier to report, as well as demonstrating charts. And actually, that's what statistics generally do. Once all information we have were stored in a structured format like this table, we can name it a dataset. A dataset has rows and columns, and each column contains a set of information for different cases, and we name it variable. Each row represents all information for the same case, and we name it record. Each cell contains a specific piece of information for a specific case, and we name it data value. And finally, all data values under the same variable are called data. Now, it's time to know the different types of data. There are two major types of data: numeric data or numbers, such as the number 23. Type 2 are string data, or simply as known characters, such as the name Ahmed. And if we have a string containing numbers, they will be treated as normal characters, such as an email address.
There are two types of data.
The core difference between numeric and string data is that we can do any sort of calculations on numbers, but it's impossible to do the same with characters,
such as the name Ahmed.
Before explaining the different types of variables, it would be better to explain first what does variable mean. A variable is a question which can have more than one answer. For
If
example,
that, we can do
when
any
asking
sort
a
of
group of people
calculation
the
for
same
numbers,
question, such as,
but for
how old
sure,
are you?
it's impossible to
They
do the
will
same
all
with
reply to
counts.
the same question, but with different answers.
Before explaining
And
the
that's
different
why
types
it's
of
called a
variables,
variable.
it would be better
There are
to
two main types
explain
of variables:
first what this
quantitative
variable is.
variables, and
A
this
variable
type
is
must
a
contain
question
numeric data,
which can have
whether
more than
the
one
data
answer.
values have
For
fractions or
example,
not, such
when
as
asking
variables
a group of
age
people the same
or income.
question, such as
We
how
refer
old
to
are
this
you,
type as scale variable,
they will all
and that
reply to
means
the same
we can do
question,
calculations
but with
on this
different
data.
answers.
The other
And
type
that's why
is qualitative
it's
variable.
called a variable.
This means
There
this
are two
type
main
can
types of
contain
variables:
numeric or string data,
quantitative variable,
but in case
and this
each
type
unique
must
data
contain
value
numeric data,
will be
whether
recognized
these
as
data values
independent
have
subgroups,
fractions or not,
and no calculations
such
could
as
be done
variables
between
age
these
and
groups,
income.
because each one
We refer
will
to
be
this type
considered
as
to
scale
have
variable,
its own
and
characteristics,
that means
which
we can do
will never
calculation on
intercept
its
with
data.
others. For example,
The other type is
variable gender.
qualitative variables.
The variable gender
This type
can only
can
has two
contain numeric or
subgroups,
string data,
males or females.
but in this case,
It's impossible to
each
calculate the
unique data
difference
value will
between
be
the two
recognized
subgroups,
as independent
because
subgroup,
they are string data,
and no
and each subgroup
calculations could
has
be
its
done
own independent
on or
characteristics.
between these groups,
Another
because
example is
each one
variable
will be
education level.
considered to have
But
its
this
own
time let us
characteristics,
assume that it has
which will
only
never
three data values,
intercept
which
with
are
others.
1,
For example,
and 3.
variable gender.
We can notice
The
that
variable
the
gender
data type is
can
numeric,
only has two
but
subgroups,
in this case
males
they
or
are not
females.
representing numbers, but
It's
three
impossible to
independent
calculate the
subgroups,
difference between
and
the
we
two
call
subgroups
this dummy coding.
because they are string data.
Finally,
And
if there
each
is no
subgroup
rank
has
between
its
these
own
subgroups,
independent
such as
characteristics.
variable gender,
Another
we refer to
example
it as
is the
a
variable
nominal
education
variable.
level.
But
this
if
time,
there is,
let us assume
we
that
refer to it as
it has
ordinal
only three
variable.
data values, which are
We
1,
name these different
2,
ways of
3.
treatment with variables,
We can
and
notice
which
that
are
the data
nominal,
type is
ordinal,
numeric
and
now,
scale
but in
levels
this case,
of measurement.
they are not representing numbers,
The
but
conclusion now
three
is,
independent subgroups,
if we have a variable
and we call
containing string
this
data,
dummy coding.
it will be impossible to do any
Finally,
calculations on
If
its
there
data,
is no rank
and
between
never
these
can have a
subgroups,
scale measurement
as
level,
variable
such
gender,
as variable
we
education level,
refer to it as
if it
nominal
has
variable.
3 data values,
But
such
if
as
there
low,
is,
mid,
we
and high.
refer to it as
No
ordinal
calculations could be done between
variable. One
all
last comment.
subgroups, so
We name these
it's more
three
logic
different
to
ways
set
of
a nominal
treatment
measurement level to
variables,
these variables.
and which
But
are
here we can
nominal,
sense that there
ordinal,
is
and
an
scale
obvious rank
levels
between these
of measurement.
subgroups, and the proper level of measurement
The
should
conclusion
be
now is,
ordinal.
if we have a variable
On the other
containing
side,
string data,
if we have
it
a
will
variable
be
containing
impossible to do
numeric
any
data,
calculations
then
on
we
its
may
data,
face two scenarios.
and never
The
can
first scenario
have a
is to
scale
treat
measurement
these
level,
numeric data
such
as
variable
independent
education
subgroups,
level,
or as
if it
mentioned
has
before,
key data
dummy
values,
coding.
low,
And in this
mid,
case,
and
we can
high.
consider this variable
Therefore,
as
no
qualitative,
calculations could be
and
done
could have
between
nominal
all
or
subgroups.
ordinal level
So,
of measurement.
It's more logic to set a
The second
nominal
scenario
measurement
is to
level,
treat these
to this
numeric
variable.
data as normal
but
numbers.
here we can
But in this
sense that
case,
there
we
is
can do any
an obvious
calculations on
rank
its data,
between these
and we
subgroups,
can say that
and the
this
proper
variable has a scale
level of
measurement level.
measurement should be ordinal.
Now, it's
On the
time
other
to
hand,
understand
if
why
we
do
have a variable
researchers
containing
usually deal
numeric
with
data,
data samples.
then we
Let us
may
assume
face
that
two scenarios.
there is a governmental
The first scenario
organization
is to
that
treat
needs
these
to
numeric
calculate the
data
average
as
income of
independent
all
subgroups,
citizens.
or as
If this
mentioned before,
organization
dummy coding.
doesn't have all
And
income
in this
data,
case, we can
it will have
consider
to collect
this
data
variable as
via a
qualitative
survey or a questionnaire,
and could have
and for
nominal
sure
or ordinal
this
level
will
of
cost them
measurement.
too much time.
The second scenario is to
efforts.
treat these numeric data
The
as
only
normal
alternative
numbers.
way here would
And
be
in this
by
case,
selecting a
We
sample
can do
of
any
citizens,
calculations on its data,
and collect
and we can
income
say
data
that this variable
for this sample only.
has scale measurement
Then
level.
generalize it to the entire population.
It's time to understand
And this is
why
what
do
inferential
researchers
statistics
deal with
generally
data
do.
samples?
It is to
Let us
generalize
assume that there is
statistical
a governmental
measurements
organization
from samples
that needs
to population.
calculate the average income of all citizens.
For now, we will not
If this
focus on
organization
inferential
doesn't
statistics
have
itself,
all
such
income
as
data,
regression
it
analysis,
will have to collect
because it's
data
already
via
covered
surveys
under
or
advanced
questionnaires.
topics.
And
But
for sure,
for now,
it will
we
cost
have
them
to know
too
first
much
how to make
in
sure
addition
that
to
the
time
collected
and
sample
efforts.
already reflects
The only
the overall
alternative
behaviors
would be
of its
selecting a
population.
sample of
In other
citizens
words,
and collect
so as we
income
just
data,
mentioned in
then
our previous
easily
example,
calculate
the selected
average
sample
and then
of
generalize it
citizens
to the entire
in this
population.
society have
And this is what
to
inferential statistics
represent
generally
all
do.
categories in this
For
society.
now, we will not focus on inferential statistics.
There are
such
many
as
methods of
regression
sampling,
analysis,
such as systematic,
because it's covered
clustered,
under advanced
stratified,
topics.
and random sampling.
But now, we
And
have
each
to know
method
first
has its
how to make
uses,
sure
and
that
the sampling
the
method
collected sample
depends on the
truly
research
reflects
objective.
the general
We
behavior
will focus on
of
random
its
sampling
population.
as it is
In
the
other
most
words,
popular one
the selected
and the
sample
most
of the
widely
purpose of
used with
sample
research.
must have all
Random
categories
sampling
in the
is
society.
the most reliable sampling
Else
method
it will not
because
reflect
almost
the true
everything
nature
in life
of the
is
population.
occurring randomly, such as heights of
There are
people.
many methods of sampling.
We can notice
such
that
as
the majority of
systematic,
people around the
clustered,
world have
stratified,
average
or
heights,
random.
while
Each
there are
method
a
has
few
its
people
uses,
who are
and the
extremely
sampling
short
method depends
or
on the
extremely
research
tall.
objectives. We will focus on
If any random
sampling,
sample
as
follows
it's
this
the most
shape, as you
popular
can see
one
here,
and the most widely
this shape
used
of
for
distribution, then
research.
we
Random
can say
sampling
that
is
this
the most
sample is
reliable
normally
sampling method,
distributed,
because
and
almost
then
everything
we
in
can
life is
generalize
occurring
its
randomly,
statistical
such
measurements
as heights of
to its
people.
entire population.
We can notice that the majority of
Once
people
a random
around the world
sample was
have
collected,
average heights,
it has to
while
pass
there are a
through
few
main
people
three
who are
measurements, which
extremely
are
short or extremely
measurement of
tall.
central tendency,
If any
measurement
random
of
sample follows
dispersion,
its shape
and measurement of the
as
shape
shown
of distribution.
then we
These
can
measures
say that this
will
sample
tell us
is
if
normally
the
distributed,
sample is
and
normally
we can
distributed
generalize
or not.
its statistical
And
measurements
if it is,
to the entire
then
population.
we can apply inferential statistics
Once a random
on this
sample
sample.
was collected, it has to pass
As a first step, we
main
start
three
with measurements of
which
central
are
tendency,
measurement of central
which are
tendency,
the mode,
measurement of
and which
dispersion,
is the most
and measurement
frequent
of
data
the
value,
slope of the distribution.
to the mean,
As a
which
first
is
step,
the average of
calculate
all
three
data
values.
values,
The
and
mode,
finally the
which
median,
is the most frequent
which is
data value,
the halfway rank data
the
value
mean,
after
which is the
sorting
average
data
of all
ascending
data values,
or descending,
and the median,
as
which
for
is
this
the
example.
halfway rank data value after
And
sorting
in case
data
of we have an
ascending
even number
or
of records,
descending, as
we
shown.
pick both half rank data
As we
values
discussed
and
before,
calculate
it's
their
impossible
average,
to do any
and this
calculation
is
on a
the median
quantitative
of an
variable,
even number
whether
of
it's
records.
nominal or ordinal. That means,
As we
for
discussed
example,
before,
we can't
it's
calculate
impossible to
an
do any
average.
calculations on a
Also,
qualitative variable,
We can't
whether
observe
it's
the
nominal
median
or
of
ordinal.
a qualitative variable.
That means, for example,
unless
we can't
it
calculate
has
an average.
ordinal level of measurement.
Also, we can't
and has
observe
odd
the
number
median
of
of a
subgroups.
qualitative variable
The mode
unless
can be
it has
observed at
ordinal
any level of measurement.
level of measurement
And finally,
and has
all
odd
measurements
number
of
of
central
subgroups.
tendency could be calculated.
The mode can be observed
all
in
scale
any level
variables.
of measurement.
The second set
And
of
finally,
measurements to
all
assess normality
measures of
are
central
measures of
tendency
dispersion.
could be calculated
The
for
simplest
scale
measures
variables.
of dispersion are the maximum data value,
The second set
the
of,
minimum data value,
measures to assess
and their
normality are measures of dispersion.
interquartile range,
The simplest measures of dispersion are the maximum data value, the minimum data value, and the range. The interquartile range is the range between the minimum and maximum data values after excluding the lowest and highest 25% of data values. This helps to identify data outliers and extremes. One of the most important measures is the standard deviation, which is the average distance of all data values from the mean. The value of standard deviation indicates if the data values are close or far from each other. The variance is the square value of the standard deviation, and it reflects the data spreading. By applying the same concept of the difference between scale, nominal, and ordinal levels of measurement, we can say that we can observe and calculate all dispersion measures for a scale variable. But on the other hand, none of these measures could be calculated for qualitative variable unless it has ordinal level of measurement and has a number of subcategories. There are two measures of the shape of the distribution. The first measure is skewness, which measures the degree to which cases are clusters towards one end of the distribution. As far as the measures of mean, median, and mode are equal to each other, this indicates that data values are distributed symmetrically around the mean. If the mode is smaller than the median and the median is smaller than the mean, then the majority of data values are distributed on the right-hand side of the mean. But if the mean is smaller than the median and the median is smaller than the mode, then the majority of data values are distributed on the left-hand side of the mean. The other measure is kurtosis, which measures the peakness of a distribution. If it has a zero value, this indicates that data values has the same distance between each other. If it's positive value, this indicates that data values are very close to each other and to the mean. But if it has a negative value, this indicates that data values are far from each other and from the mean. The conclusion now is to assess normality, we have to collect some measures, such as the mean and the median and the mode. And if they are equal or approximately equal, then we will move to the next measure, which is the skewness, and then check if it's 0 or approximately 0, and then move next to the kurtosis and check its value, and so on. And for sure, we have to check the distribution chart of our data values. And for sure, it's very important to check for outliers or extremes in our data. And this we can do it by the interquartile range, as mentioned before, which could be represented by boxer plots. If we want to distribute a qualitative variable, then we should use bar or pie charts. But if we are trying to distribute a scale variable, then we have many options such as scatter plots, histograms, and curve. Finally, I would like to thank you for your time. and watching this video.